Hey everyone, today we are going to be building something really cool, a service discovery app for Bali, where you can find the best gyms, restaurants, coffee shops, co-working spaces, you name it. The best part? We are going to be pulling the data from the web automatically. Let's get started. We are going to use Next.js, TypeScript, Tailwind CSS, API endpoints to serve dynamic data, and Firecrawl to scrape real data and to do some reasoning for us. First, we'll scaffold a fresh Next.js project with TypeScript and Tailwind CSS. This gives us everything we need to build a modern web app quickly. Now we have our project installed, so let's run it. npm run dev. And here we have it. We don't need any of this, so we can remove it. Say hello for now. We're going to organize our API's routes into separate folders. And in each of these, we are going to have routes. We just created an API endpoint per service that we want to have. Let's just add some configuration to our project. So in tsconfig, I am going to add here some configuration that I always have in other projects. So here is all the configuration I have. You can pause the video. I also need to configure Tailwind CSS at the configuration here. Okay. We are going to need an env file for variables. So let's just do that now. .local. There are more configuration that we need to do to the next config, but before doing it, let's go back to the homepage and start building the header. I don't want this, so I'm gonna remove all of that and just say background white. So for the top, we have a header, so it's gonna add here a div and an image. So for our top header image, I'm going to use a free one from Unsplash and just click on copy image address, paste it here. Save this and let's go to the browser. We have our first error here, which is telling us that the images coming from Unsplash is not configured under images in our Nest configuration. So let's go back to this file. This is a very important part because Next.js has a security feature where you can't load images from random URLs on the internet. You have to explicitly whitelist which domains images can come from. So the first thing, let's just add restrictive mode. This tells JavaScript to run React in strict mode during development. And then we are going to add our images. Configuration, protocol, HTTPS, hostname, images, and splash. Here we need to add more rules for images because when we scrape websites, the images could come from a variety of domains. But we are going to see this a bit later. So now we save this. Yes, we can see the image now. Since this is not a UI tutorial, I'm gonna go ahead and start building the UI and the CSS, and I'll be with you in a second. This is how our UI looks like. Let me just show you what we did. We have here the filters, coffee shops, restaurants, gyms. We have the image, the header, then we have the form here. We need to create this function, handle search. We have here all the CSS of the cards, so you could just take it from the repo, you don't need to add it. If we have an error, we are going to display here the error. If we get results, this is where we are going to display the results. It's going to be a grid of cards, which each card is a link that links to each specific service. Okay, let's go to the top here and start adding our functions. But before, we need to add a few use states. Since we cannot use state in server components, we are going to have to convert this into a client component. We need to create an area. This is what is going to determine which area we have. We need to create a state for filters, then another one for results, okay, and loading is going to be false by default and for the error. Now we are going to create the main search function. This function runs when someone either submits the search form or click the filter button. It's going to receive two arguments, the form of event and the selected filter. First, we need to stop the page reloading, and also we need to check if it's empty, and we just exit the function here. Now we need to figure out which filter is active. If there is no selected filter, it will use whatever is the current filter. And now we need to set the loading to true. We clear any errors that we might have, set the results to an empty list, and set the filter to the active filter. Now we need to figure out which API route to call. If they select coffee, API/coffee. You get the idea. So we use a try-catch block to handle any errors that might happen during the fetch. The first thing is we are going to define an endpoint. The endpoint is going to be API coffee area, and we are doing this to make sure if someone types weird characters, it gets safely converted to a URL format. So we fetch data from our API and we need to await for the response. And now we need to convert it into JSON. So const data await response.json, and then save the results so the page updates with the new data. So here, if we get an error, we are gonna set an error, fail to fetch services. Please try again, just like that. And finally, set loading to false. So if something goes wrong, we show an error message, and no matter what happens, we always turn off the loading spinner at the end. Here we also have another function that we need to implement, handle first click. So basically, if you already search for Canggu and then you click the filter gyms, it immediately searches for gyms in Canggu without you having to click the search button again. Okay, this is not working. It's not selecting, so let's go back to the code. I forgot to pass selected filter. Okay, if we go back, now it works. Let's start with the first route that we have here, which is coffee shops. Let's go into it. We are going to first import the Nest request. Let's create the get request. What this endpoint is going to do is when the front end asks, hey, what coffee shops are in Canggu, this endpoint responds. So first we need to get the area from the URL. If they didn't include an area, we send back an error. I'm going to use mock data just so we can test the UI. In most cases, you probably need this step to understand the data structure that you need. So now we can use it here. So I'm just gonna create a new const, call it list, and coffee shops, and pass the area. If we don't get any list, we want to return a response message. It's no coffee shops found in this area. Now, if we do have a list, we want to transform the names into proper objects with the shape that the front end expects. And now we just send back the results as JSON.json and data results source mock only. And we are done with this endpoint. Canggu. And we can see here our list. Ubud, Uluwatu. Okay. So far we have a working app using mock data, but let's get real. Getting structured, clean, real data from a website, it's hard. It would be impossible to create a production-ready app by you manually going through the different articles that are out there that talk about restaurants in a specific place and manually taking all the restaurants and all the information about it. You could try using basic HTML scrapers, but many sites use JavaScript heavily and it won't work with simple parsing. The data tends to be messy and unstructured, and you'd spend hours creating custom parsing logic. But what if there was a better way? That's where Firecrawl comes in. It's the web API for AI. It turns any website into clean LLM-ready data. LLM, large language model. It has over 60,000 stars on GitHub and is used by a lot of AI startup projects that need to turn websites into usable data without writing their own scrapers. Firecrawl has several powerful endpoints. Start to search the web and scrape results in one call. Scrape to scrape a single page. And yes, including the JavaScript rendered content. Map is the easiest way to go from a single URL to a map of the entire website. Crawl to recursively extract data from multiple pages on a site. And finally, extract to get any data in any format effortlessly in a single API call. Just describe what data you want to extract and Firecrawl handles the rest. You get structured data in seconds. Works on any sites, no configuration needed. For our app, we are going to work with a few of these endpoints. You can go to their website and come here to the blog and explore all the different apps you can build. There are pretty impressive things here. You can test Firecrawl for free. They give you 500 credits, which is really generous, and it's definitely enough to build this small project and experiment with it. Thank you, Firecrawl, for sponsoring this video. Let's start by installing Firecrawl. So npm install Firecrawl. So once you sign up, let's go to API keys here. Click here in copy, and then you're going to go to your env local. I'm just going to show you in the example how it's going to look like. And you're going to add the key here. Let's go to the next configuration. Remember how earlier I told you that we need to add a few more things here. So let's add Firecrawl. So here the wildcard means any subdomain, so any .com. This is practical for scrapers, but if you wanted to be more restrictive, you could specify exactly the domain like we did here. We are going to focus in the gem root. We are going to import, now that we have it installed, Firecrawl. Okay, and similar to what we did before, we are going to say if there is no area, return next response.json error area parameter is required. All right, so before we go through the steps, I need to add a couple of helper functions that we are going to need in every API route, just for simple validations. So let me explain to you what I did here. If there is no area or it's not a string, throw an error. So if it's empty, we just throw an error. Area cannot be empty, and if the area has more than 100 characters, then the area is too long and is invalid. Otherwise, return the area. Validate area name, and now we are gonna go back to our root and import it here. Okay, and we are gonna catch here any error that we might have. And here we are gonna do the same as we did before. We are gonna return an error with the message, and I'm missing here the area. Let's write here the steps that we need to follow. First, step 1, search the internet for articles about gyms in a specific area and limit to 10. So the first thing we need to do is get our API key. So this is the API that we put in our env file earlier. So if we don't have an API key, throw new error. Now we need to create a connection with the Firecrawl service. For that, we need to pass our API key so Firecrawl knows who we are and that we have permission to use it. So const add new Firecrawl, and here we pass API key. So let's come here to the playground and test how it works first. So if we go to search, which is the first one that we are gonna start using, we are gonna say the best gyms in Canggu, Bali, and let's see what it shows us. Okay, it's gonna show us all of these results. So the ultimate guide to the best gyms in Bali, the 22 best gyms in Canggu, what is the best gym in Canggu, 16 gyms in Canggu. So what we want to do is pick an article with the highest numeric list. So for example, this one here that says the 22 best gyms in Canggu will be the one that we want to have. So we do the same here. We call the search endpoint and we pass the test we want to search for. Best source, let best number. Okay, what we are doing here is we are going to look through each search result and find the article with the biggest number list of gyms. So first, we are going to check if these have a title property. Now we use a regex pattern to search the title to match things like the 22 best gyms or the top 16 gyms. If there is a match, we capture the first thing. So now if number is bigger than the best number equal num, and best source, and this should be item. Okay, so here we have our loop. Now we should add a fallback. So if no number list is found, we are going to choose the first gym related result. Ensure best source has a URL property. If the best source doesn't have a URL property, then we are returning no source found. In step 3, we are going to scrape the article as HTML. Await app. Let's just go into the playground and check it out. So let's say our whole logic, our search chose this URL that we have here. I'm gonna copy it. Gonna go to scrape. I'm gonna paste it here and start scraping. And here we can see the markdown and the JSON that it returns. Let's just focus on the markdown. We can see a list of gyms. And yes, all of these are gyms in the Canggu area. It's crazy how many gyms are in such a smallest place. So we can see here the table of contents, and the first few things is factors to consider choosing the gym. So that is not a gym. These are, but these are not. So we are going to have to create some logic to extract the gyms from this markdown. Let's go back to the code. Here we are going to pass the best source that we found. And we could ask for the markdown as I showed you, but here we are going to specify HTML. And now only main content to true. And this is important because websites are messy. They have ads, sidebars, navigation, footers, menus. So this tells Firecrawl, strip away all the junk and just give me the actual article content. So first, let's check if we actually got any HTML. Why wouldn't we get an HTML? Well, maybe the website blocks us, or it's down, or something went wrong with the script. As we saw, we are going to get an HTML that is going to be a bit messy. It's going to include headings or links to other things. So we need to implement few strategies to extract a clean list. So for that, I am going to create a function. So I'm going to go here at the bottom. And here I'm going to pass the HTML, an area, and source URL. We are finding all the links in the HTML. Find all the opening tags, capture whatever is inside, and then find the closing link tag. Find all of them and be case insensitive. This here is for remove any HTML tag from the link text. There's another function I want to create to check if it's likely what we got is a gym name. So first we check if we have passed a name. And then we clean the name, and here we have a list of words that we are going to exclude, because as we saw earlier, there were words like factors, comments, Instagram, thoughts that are not entries for gyms. First, we are going to loop through the array and check if the clean name matches any of those patterns. Most gyms only has 1 to 5 words, right? So we want to reject if it's too long. Most real gyms usually use one of these keywords: fitness, studio, club, CrossFit. So we added here another check. Otherwise, we are going to just accept anything if it looks like a proper name. I can now use this up here. So now, if it's actually a gym name, we add it to our gyms array. I want to create another helper function to create gym objects in the right way. So make gym. This is what we are returning: the name, the type gym, category gym, address, area, Bali, and the source. Text, area, and the source URL. Right, almost there. If we found any gyms from the links, we should remove duplicates and return them immediately. So I'm going to create a new function. Here we are looping through each gym. Then if we have seen this gym before, then we return false and we skip it. We don't include it in the results. But if we haven't seen it before, then we keep it. I like to add here 3 more fallbacks. And we are using the exactly same structure that we used here for the first option. I create an array with our heading matches, and I also use the slightly gym name function, and if it is, then we push it to our make gym object. Okay, if this doesn't work, then we fall back to the bold text. If this doesn't work, then finally we fall back to a list of items. And then we return the dupe function to remove duplicates. Now we can use this function in our response. So yes, let's come here, const gyms, and exactly this, extract gyms from, we pass in the scrape HTML, the area, and the best source URL. Now we are going to return this, Firecrawl search plus scrape. I'm going to wrap all of this in a try catch block, just so we can pass a catch error. So try from here all the way down here, and then we can catch the error. Cool. Let's test this. We've done so much work, and let's just see how it looks. So we can claim here gyms and just type Django and search. Okay, so we get some data back, but we're getting results that are not gyms. So we are getting price, format, related posts. So these are gyms: Body Factory, Nirvana, Run Gym, but not this. So let's go back to our function and see what is going on. And I think I know I forgot to close this one here. I was missing a bracket. And now we are getting the list. Yes, this is pretty cool. Look at this. Wow, we are getting a list of all the gyms there are in Canggu, which, as I said, there are many gyms. This is really cool. What if there is even a better way of doing this? We are going to use extract for our restaurants API. And extract endpoint simplifies collecting structured data from any number of URLs. It provides a prompt where we can describe the information we want. So Firecrawl will handle the details of crawling, parsing, and collating large or small data sets. I was telling you earlier that we are going to use their LLM reasoning to do all of this work for us, so we don't actually need to write much code. In the root restaurants, I've already added the basics that we are going to need for this endpoint. Here we are being a bit strategic about our source. I decided to provide a curated URLs of articles, websites that I know includes good restaurants. We are exporting a GET request, and the first thing that we do is get the area parameter. First, we are going to use the same helper that we use for the gyms, validate the area name, and we have it here. We convert the area to lowercase, and then we use the area as a key to get the list of restaurants URLs for that area. And here we are establishing a connection with Firecrawl. This is where the magic happens. Here we are going to call the struct API, const struct results. So await app. And we are gonna call it with three things: URLs, prompt, and schema. The URLs is the page we want to read. Prompt is what we want in plain English.
Extract all restaurants' names from this page and return only the restaurant's name as a JSON array of a string.
And the schema. Here we are going to define the shape of our data.
The LLM will read this page, understand your prompt, and return the data structure according to your schema.
Let's add another step, step 3, which is handle the response. We need this function because we don't know what shape extract will return the data in. So here, if the data is already an array, we are filtering it to keep only the strings and remove any numbers or objects. But here, if a data is an object with a restaurant property, we are going to grab that array and filter it for strings. So we extract the strings either way. I'm going to need another step here, so I'm gonna add it here. Step 4, which this is going to be for build restaurants objects with the data we got.
The LLM will read
here
this
what
page,
we are going to do is look through
the
each
structure and return the
name we
data
extracted.
according
And
to
for
your
each
schema.
one, we are going to remove the extra space with trim, and we are going to skip it if it's empty after the trimming. And now we are going to create a restaurants object with all the details. For that, I'm gonna come up here and define a const. So all restaurants, and we are going to use the type that we define up here, restaurant, and it's gonna be an empty array. Okay, so now we can come down here and continue. So here we are creating a restaurant object with all the details that the front end requires: the name, type, address, and category. So this is going to add it to the all restaurants list, and by the end we will have a full list of restaurants objects ready to send back to the front end. We're just gonna console the error URL and error. Let's just add step 5 here, which is going to be for remove duplicates and return. Now we have a unique list of restaurants without duplications, so we can use this unique here to pass it down into the response. I think that's it. Now let's test it. Okay, let's come here. Let's write Canggu, click in restaurants, and we can see the result with all of our restaurants. Wow. This is pretty cool, guys. I'm not sure what you think, but this is pretty amazing. It's a lot simpler than what we did with the gym's URLs, and look at this. And now let's just try another one. Let's just say Ubud. And here we have new results only for Ubud. As you can see, Extract is a game changer because it uses AI. The LLMs understand what restaurants are and finds them intelligently. Okay, so let's just go through everything we did. In the UI, we have a search interface with filters, pulls multiple API endpoints, and display the results in a grid. Then we have the coffee route. Here we are hard-coding the data, but it's perfect for testing. For the gym URL, we search for articles with list. We scrape the HTML. We used helpers functions to parse the data. What is really good about this approach is that it's very flexible and can handle many different HTML structures, and you are in control of the exact logic. And it's also faster than using the extract endpoint.
I also built a service detail page, so when you click on a gym or restaurant, you get richer information instead of just a name. On the back end, I created a details endpoint. It takes the service name, searches for the official website using Firecrawl, and filters out noisy results like blogs or guides. Once it finds a real site, it scrapes the main content and then uses Firecrawl's extract endpoint with a schema to generate structured data. If there's no website, it gratefully falls back to Instagram or just returns basic info. On the front end, the details page simply calls that endpoint on the server. I render images from the scrape, then display the structured data returned by extract. So instead of raw HTML, you get readable AI-generated sections like about, what they offer, and key features. The important part is that the UI stays simple, and all the heavy lifting happens in the API using Firecrawl.
So that's it. We created a fully functional service discovery app with real data. You now have everything you need to build more features. So here's your challenge. Go to the co-working route, and I challenge you to get the data using the other two endpoints that we haven't covered in this video, the map or the crawl. Play around with them and see the difference between the ones we use today. The power here is that this same pattern works for any website: job listings, job boards, real estate, news aggregation, product listing, articles, you name it. And let me know in the comments if you have any issues, if you managed to do it, what you think about Firecrawl, and if it's something that you would use in one of your personal projects. Thank you for watching.